Hello everyone. In today's class we shall study three concepts, that is inverse function, sequence and summation. So what is this inverse function? See, in the last class we studied what is function. What is function actually? Function is represented by a small letter f, and function means you will be having two non-empty sets A and B. Okay, and it is represented as relation from A to B, and there is one element A in A and there is another element B in B. So always it is B means f of A, where B is the image of A and A is the pre-image of B. This is what we studied as function. Okay, now inverse function means what? As the name indicates, it is exactly reverse of the function. So as we know, there is a set A and there is a set B, okay, and there is an element A and there is an element B in B, A in A. So always the function means the relation from set A to set B. That means from A to B. This is how we indicate the function, and the symbol is f, and it is written as B is equal to f of A. So what is B here? B means f of A. Now exactly reverse means the relation from B to A is. In that case it is represented as f inverse. So A means what? F inverse of B. For example, in general if we write f of 2 is equal to A, then the inverse will be f inverse of A is equal to 2. So this is how we mention the inverse function. Now let us study some examples. See here, A is equal to ABC and set B is equal to 1, 2, 3, such that f of A is 2, f of B is 3 and f of C is 1. Okay, so this is the set given here. So we have to find out the inverse of this. Now let me write the function as it is given. So we are having set A and we have set B. What are the elements of set A? A, B, C. So A, B, C. What are the elements of set B? That is 1, 2, 3. 1, 2, 3. Okay. See here. What is f of A? 2. So f of A is 2. Next, f of B is 3. So f of B is 3. Next, f of C is 1. Now, what is the reverse? So reverse will be exactly C. When f of A is 2, then its reverse will be f inverse of 2 is A. Okay. Next, f of B is 3. That means inverse is f inverse of 3 is B. Next, f of C is 1. Inverse will be f inverse of 1 is C. So this will be the inverse of the given function. Next, let us consider one more example, that is f of x is equal to x plus 1. So here they have given you the expression. Find out whether it is reversible or not. So how to find it out? Let us put some values. F of minus 2 will be minus 2 plus 1, that is minus 1. F of minus 1 would be minus 1 plus 1, that is 0. F of 0, 0 plus 1, that is 1. F of 1 means 1 plus 1, that is 2. F of 2 will be 1 plus 1, 2. 2 plus 1, that is 3. So we got the respective functions. Now we have to represent this in the form of sets. So we are having, this is set A and this is set B. Okay. So now here we are having x values and here y. Y is nothing but f of x. Okay, so what are the x values we have? -2, -1, 0, 1 and 2. These are the x values. Then y values, nothing but f of x. That is -1, 0, 1, 2 and 3. So now, what is f of -2? -1. So this is the function. F of -1 is 0. F of 0 is 1. Similarly, f of 1 is 2. F of 2 is 3. Okay. So this means this function is reversible. Why it is reversible? Because it is, as we studied in the last class, it is 1-to-1 function. So 1-to-1 function means what? There is dedicated image as well as a pre-image. Okay. Now we shall study one more example based on this. That is f of x equal to x square. So similar to that one, what is the expression we have? F of x equal to x square. Now let us take the values as it is. So f of -2 is -2 whole square, that is 4. Next, f of -1 will be -1 whole square, that is 1. F of 0 will be 0 whole square, that is 0. F of 1 is 1 whole square, that is 1. And f of 2 is 2 whole square, and that is 4. Okay. Now again represent it in the form of sets like this. So this is A and this is B, nothing but this is X and this is Y. Y is nothing but f of X. So here we have X values as -2, -1, 0, 1, 2. And here the corresponding values are, see here, we are having 0, 1, 4. When we have such values, see, f of -2 is 4. F of -1 is 1. F of 0 is 0. Again, whereas f of 1 is 1. Okay. F of 2 is 4. Okay, which is already there. That means this is not 1-to-1 function. Therefore, this function is not reversible. Why it is not reversible? So we can reverse a function or inverse of a function means what? Where we are having only 1-to-1 function. Only that can be reversible. The remaining cannot be reversible. Means what? For one image, there should not be more than one pre-images. Therefore, this is not reversible. So this is about inverse function. Okay. Now let us study the sequence. Now about sequence. What is sequence? As the name indicates, sequence means it is a list, we can call it as, in general. In general, sequence means a list. So here the sequence means it is a discrete form of an ordered list. Okay. For example, it will be always integers. Okay. So if you consider the whole set of integers, then we are considering only a part of integers. A part of integer, we can mention it as a subset of set. Okay. So how to define sequence? A subset of set of integers. It is the relation from a subset of set of integers to a set. Yes. Then what is this set? See, in general we can write it as A1, A2, A3 and so on up to N. And here the set is noted as AN, where A1, A2 are the terms of the sequence. And see, I hope you remember, you have studied in high school, that is arithmetic progression. So what is the formula for arithmetic progression? That is A plus D, A plus 2D and so on up to A plus ND. Okay. So what is A here? A is nothing but the first term. And what is D? D is nothing but the common difference. Okay. See, for example, if A is 3 and D is 2, then what will be the sequence? See, A is 3, comma, D, 3 plus 2, 5. Next, 3 plus 2D means 2 2s are 4. That is 3 plus 4, 7. Next, you will be having 3 plus, A plus 3D. So, A is 3 plus 3 2s are 6. That is 9 and up to. Okay. So, this is about what? Arithmetic progression. Similarly, we are having GP. That is geometric progression. So, what is geometric progression in the formula? AR, AR square, AR cube, and so on up to AR raised to N. So, where again A is the first term, and what is this R? R is nothing but the common ratio. Okay. See, for example, if A is 1 and R is 2, then what will be the sequence here? 1, comma, A into R, 1 into 2, 2, A into R square is 4, 4 into 1, 4, AR cube, 2 cube is 8, 8 into 1, 8, and like that. Okay. Now, the popular sequences are nothing but Fibonacci series and factorial. So, what is Fibonacci series? See here, Fibonacci series, here we are having F0 as 0 and F1 as 1. And the formula is Fn is equal to Fn minus 2 plus Fn minus 1. Means what? To get the next number, we are supposed to add the present number with the previous number. For example, see here, the first term is 0, second term is 1. Now, how to get the third term? That is 0, 1, now 2. That means N is 2. So, F 2 minus 2 plus F 2 minus 1. Therefore, F0 plus F1. That is 0 plus 1, that is 1. So, the next number in the series also 1. Similarly, F3 means F3 minus 2 plus F3 minus 1. F1 plus F2. So, what is F1 here? F0, F1. So, F3 is nothing but F1 plus F2. That is 1 plus 1, that is 2. So, the next term of the sequence is 2. This is how it continues, and this is nothing but a Fibonacci. Similarly, the factorial. So, what is factorial? 1 factorial means 1 into 1. So, 1 factorial means 1 into 1, that is 1. 2 factorial means 2 into 1, that is 2. 3 factorial means 3 into 2 into 1, that is 6. 4 factorial means 4 into 3 into 2 into 1, that is 4 3s are 12, 12 2s are 24. This is how it continues, and this is nothing but the factorial. Okay. So now the next one is summation. As the name indicates, summation means what? Sum of the terms of the sequence. Okay. So whatever the elements we have in the sequence, we need to add those. Okay. So this is very simple. A1, A2 and so on up to AN. If this is the sequence, we need to add these all, like A1 plus A2 plus and so on up to AN. So this is nothing but the summation. So for example, summation J equal to 1 to 5 and here it is J square. Okay, this is what summation given. So here J values we have to take from 1 to 5. So it becomes 1 square plus 2 square plus 3 square plus 4 square plus up to 5 square. So this is the sum of the terms. So here 1 square is 1, 2 square is 4, 3 square is 9, 4 square 16, 5 square 25. What is the sum here? 4 plus 1 5, 5 plus 9 14, 14 plus 16 is nothing but 30, 30 plus 25 is 55. So this is what the summation of the sequence. And similarly, for example, summation k equal to 4 to 8 minus 1 raised to k. If this is given, then how to find out the summation? See here, we just have to go on putting the values of k here. It begins with 4. So, minus 1 raised to 4 plus minus 1 raised to 5, minus 1 raised to 6, minus 1 raised to 7 and minus 1 raised to 8. See here, minus 1 raised to whatever may be the number, the result will be 1 only. But we have to consider whether it is minus 1 or plus 1. If the power is even number, then obviously the result will be even, plus. So minus 1 raised to 4 is plus 1. Next, minus 1 raised to 5, it is odd. Therefore it is minus 1. Next, minus 1 raised to 6, even, plus 1. Minus 1 raised to 7, odd, minus 1. Minus 1 raised to 8, even, plus 1. Plus 1, minus 1, plus 1, minus 1 get cancelled and remains is 1. Therefore, the summation of the elements of this sequence is 1. Okay, in the next class, we shall study the matrices.